So 2.1.4 is all about the limit laws. So you can look at limit laws and think of it as real numbers because a lot of the properties of real numbers do apply to limits. If you think of f of x as L and g of x as m, it will make this so much easier. So if you look at the first rule, the sum rule, you can look at the limit of x as it approaches a as f of x plus g of x, and then L plus m to simplify it. So you just add the real number of g of x to the real number of, you add the real number of L, that is f of x, to m. And if you look at the difference rule, it's almost the same, except minus. So you do L minus m. So as the limit x approaches a, it's f of x minus g of x, or L minus m. For the product rule, as the limit of x approaches a, f of x times g of x, or L times m. The quotient rule is almost exactly the same. It's as the limit x approaches a, it's f of x over g of x, or L over m. However, g of x cannot equal 0 because anything over 0 is not a real number. The scalar multiple is pretty much just saying any number times a constant. So as the limit x approaches a, it's c times f of x. C is the constant, so you can do c times L as the limit x approaches a. In the power rule, it's the limit x approaches a, f of x to the power of n. So L to the power of n. And that's pretty much it.
Hello, this is Alexander Estrada, and I'm recording my video. My topic is overview of limits. So I will do the walkthrough, and then my team member David will do the graphing section part of this. So the limit is the range value that a function is tending towards as you get closer to a domain value. So we get the limit value, x to 0, and we got to find the domain value that it is leaning towards. So there's a few rules. First off, both these examples are in intermediate form, and on the video it said intermediate form is meaningless, which, I mean, in a way it is, because it just shows us where we need to start. So first and foremost on this first one, it is the limit value of 0, and you have 1 over x minus 3 plus 1 over 3 all over x. So first and foremost, if you plug 0 into any of these, you're going to end up with 0. So that's always a little tricky and confusing. So the first thing is, don't worry about the bottom, don't worry about that x, and just worry about this top thing, which is 1 over x minus 3 plus 1 over 3. So we're going to have to combine denominators to get similar denominators. So that's going to be 3 over x minus 3 times 3 plus x minus 3 over 3x minus 3 all over x. So if you see, we got there by combining like terms. So we did 3 over 3 on this side, and then x minus 3 over x minus 3 on the opposite side. So then again, the lim x to 0. Once again, if you plug 0 in, it's just going to be a big mess, so you want to continue to keep going. So now we were going to combine like terms. So the 3 subtracted from the 3 will actually cancel itself out. So cancel out, cancel out. So now we're left with x over 3, x minus 3, all over x. So now, to go from here, you're going to just reverse the denominator. So this is going to this will turn into x over 3x minus 3. And this is going to be multiplied by 1 over x times x minus 3. You're going to plug in the 0 right here, which will turn it into a negative 3. Negative 3 times 3 is negative 9. So your finished product is 1 over negative 9. Simple enough. You just got to make sure you go through your steps. The next one we're looking at is going to be with some exponents. So this one might be a little trickier. First and foremost, if you plug 0 in, it's just a big mess. It's 0. So the first thing is going to be to factor. So on this top part, we can take an x out. On the bottom one, we can take an x out as well. Okay. So now that the x's are out, we don't need to worry about them. And we'll look at just this right here. So there's not much else we can do. So at this point, we're going to plug 0 in. So now 0 squared is going to be 0. Minus 0, 0. 2 times 0 is 0. So you're left with 6 over 1, which is equal to 6. Fair enough. Like I mentioned before, the intermediate form, which is right here, is a meaningless problem. Once you start solving, then it has meaning. You can just not worry about these x's, and then to find limits, you just gotta solve it step by step. Thank you.
Hello everyone, this is David. I'm going to show you guys the process of analyzing graphs on limits. And the first thing that you really want to look at during this time in this overview is the main real question is, does the limit exist? And these are 3 example graphs that I kind of came up with to show you guys how you can tell if there's a limit or if there's not a limit. In the previous question that he worked on, we had this left, x squared minus x plus 6 over 2x plus 1. And he saw at the end of that, he had x while the limit was approaching 0, it equal to 6. And you can see that right here, where at this little really badly drawn graph this is going to be 6. So you see at where x is 0, it does have a point at 6. But at the overall equation though, we got to ask, does the whole limit exist? And as you can see where I kind of tried to make a curve is you see where the lines are actually not touching, kind of like this graph over here. And that's where you kind of see if the limit is there. So looking at this graph, since there's nothing touching these 2 endpoints, we can conclude that this graph actually does not exist. And then if we move on to this one, like I was referring to earlier, you can see that what we're really looking for are these 2 lines to be touching. Like, are they like actually going to try to connect to each other, even though that there's a little hole here. But don't worry about that. As long as the hole is there, like there's a point that's supposed to be there, that's really all we're looking for. And that's represented by this point right here. It doesn't matter why this is right here at the moment. What matters is that there is something there. But since it is approaching right there at the moment, so if we took that example, we could say, yes, this is a limit because of that point. And it would be, I believe, fx is approaching, our answer would be fx is equal to 2, I believe. And then while we take a look at this one right over here, we can see that it's kind of similar to this one, but they're still not touching each other. That's the thing that we're really looking at. And since they're not touching each other and there's like that little gap, we can conclude that this one is also the limit does not exist. And that's a little small overview of how to analyze a limit, seeing if the limit exists. And I hope this helped you guys know how to analyze it if you guys ever see a limit in graph. And hopefully it'll help you guys out in the future.